Another widely used functional form is the quadratic. Now, a quadratic is simply a fancy name for a parabola, and so this is also known as a polynomial function of degree 2. It looks like this: y equals a times x squared plus b times x plus c, where the a, b, and c are constants or numbers. In this case, a is not equal to 0. What happens if a is equal to 0 here? Well, that first term would go to 0, so we'd end up with y equals bx plus c. And this looks like our old friend, the linear function. So for this to be a quadratic, that a value cannot be 0, because then it will just default to being a linear equation. But if a is greater than or less than 0, some other value, then it takes a very specific form. So my y, my dependent variable, it's a function of x. That's that ax squared plus bx plus c. And that consists of the independent variable x, the input, and my three constants, a, b, and c. So what does this look like? Well, it's going to essentially look like a U, either facing up or down. So I have something like this. When a is greater than 0, the function is known as being convex, and we'll talk more about that in a second. And if it's less than 0, if the a is less than 0, then it's an upside down U. So they'll take one of these two forms depending on the value of a. So the a really tells me the steepness of the curve. The b is that linear coefficient, and the c is still the y-intercept. Why do I say that? Well, when x is 0, then y will be equal to c, because the other two terms will go to 0. So the c is just telling me that y-intercept when x is equal to 0. One of the things we'll need to do with a quadratic is to find the roots. What is a root? It's simply the value of x that'll give me an output of 0. What value of x gives me a f sub x, or a y, is equal to 0? In a quadratic equation, depending on the a, b, and c values that you have, there will either be 2 roots, 1 root, or no roots. And so here are 3 quadratic equations, and I'm showing the roots with those little dots, but let's figure those out in a second. So how do I figure those out? It's 2 methods. One is by factoring. You probably did this in 5th or 6th grade. I was never good at it. And you can find these roots. A lot of people are very good at this. Let me show you a different method. That's the quadratic equation. Keep this in your tool belt. And what it means is, if I have a quadratic equation in the form y equals ax squared plus bx plus c, then I can find the 2 roots, if there are 2 or 1, by this equation. Negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Now you might ask, what is this plus minus thing? Do I add it, or do I subtract it? Well, you're finding up to 2 roots. So the first time through you add it, the next time through subtract it. It might give you 2 different values. Let's do this through an example. So here are those 3 forms again. The curves, curve 1, 2, and 3. Let's find the roots of each of them. The first one, the function is y equals 2x squared. So in this case, my value of a is 2, because that's the value multiplied by the squared. My values for b and c are 0. So if I plug that in, just simply plugging in the values for a, b, and c into this quadratic equation over here, I get the value of 0 over 4, whether I add or subtract that squared term, that square root term rather. And so this is telling me I've got 1 root, and it's at 0. That's right here. Let's do another one. Let's do the curve 2. So this is where my function is y equals 2x squared minus 6x plus 4. So my a value is 2, my b value is negative 6, and my c value is positive 4. I'm just going to plug that in to this equation up here, and I'm going to get 2 different values. Right? I'm going to have it equal to 6 plus 2 divided by 4, and 6 minus 2 divided by 4. So if I plug those out, 6 plus 2 divided by 4 is 8 over 4 is 2, and 6 minus 2 over 4 is simply 4 over 4, or 1. So in this case, I have 2 roots, one at 1 and one at 2. So at the values of both x equals 1 and x equals 2, I will have a value of y of 0. One last case, and this is the functional form y equals 3x squared minus 4x plus 2. So the a value is 3, the b value here is negative 4, the c value is 2. And so if I plug this in, I get something that looks like this. 4 plus or minus square root of negative 8 over 6. Thinking back, right, to primary and secondary education math, can I take a square root of a negative number? Sure, but it becomes a complex number. It doesn't exist in our space. So they are essentially undefined for us. They're complex numbers. So in this case, there is no root, and that's what this is showing. So this is a very simple way to find roots. Quadratics are widely used, and you'll need to have this in your back pocket because sometimes you'll have to find a certain point such that the value for y is 0, and this is one of those tools you'll use.